Hello students, welcome to EduCell. In this video, we are going to discuss about satisfiability problem. Sometimes it is named as SAT also. Okay. So before going to in detail about the satisfiability problem, we should know certain things related to the SAT. Okay. The first point we should know is literals. Okay. Another is clause. Okay. Definitely conjunctions and disjunctions, which is your and is considered as conjunctions. Okay, this or is considered as disjunction. Okay, so certain things we should know. Literals means which are getting used, like the sometimes we are saying it constants also. Okay, x1, you can say a negation of x1, or else sometimes we are writing x1 in this order also. Sometimes we are writing as x1 negation. These are negation time we are saying. X1, this is just a positive sign. We are not using any symbols like this. Okay, if you're saying the negation of it, literal, suppose x1 value is 1, so in this case x bar or this one, or like this if you are writing, so the value will be converted to 0, means true. If x value is true, negation of it is 0, that you know in digital logic. Okay, so these are considered as literals for us. Next is clauses. Clauses are within a bracket. Okay, within a bracket, suppose you are taking x1 x2. Okay, this is just an or operation we are using, or disjunction we have added. This is called as a clause. Okay, within a bracket which is written, we are saying this is just a clause for us. Okay, next thing is conjunctive normal form. Then we are going towards the normal form, where it says at least three clauses. Okay, clause should be three, not more than that. Clause means three different brackets we are going to use, as well as within that at most three literals or constants we are going to use. Okay, we are going to use three literals within that. Three literals must be there, or three different clauses are there, then only we can say it is 3CNF. Okay, so you can say, as for the example, it is written xyz or xyz such like this. Okay, if you want to convert that one, you can write in this order. Okay, indirectly why I am keeping this one, suppose you are new to this, kindly check the operations how we have already done in while creating the circuit diagram, or might be while reading the digital logic. These are the options I collected. Sometimes we are writing xyz. If you are writing in this order, means it is and operation, means multiplication, and we are doing multiplication here. I'm just writing it. For multiplication we are using, for addition we are using this or operation. Okay, so if you are multiplying this same clauses now, it is indirectly one time. If you are writing x y z, so it is also enough. Okay, so I just gave an example through which you can able to know. In that case, whether we'll call this one as 3CNF, that is a big question. Okay, because we are using the same literals with the three different clauses. Can it be said as 3CNF? That is a big problem. Why? If you are saying in this order, it follows the rules also, but in this case when you substitute for satisfiability issue, it will never fall in this condition. At least you have to change certain rule, like here you have used x y z. Okay, or x y z. Next, between that you put and operation. X, you can take negation of that one and keep as it is, like to make difference with the literals which you have used. Okay, then only it is considered as 3CNF. Why? Because we are going towards the satisfiability of it. Okay, next I'm just using this one. then only we can say both the clauses are different. Okay, here it is not clearly mentioned whether the clauses are different or not. For satisfiability, whenever we are going towards the satisfiability of it, maximum time I'm using satisfiability condition. I'll tell you that one. What is satisfiability? What is dissatisfiability? I'll tell you that one. But for satisfiability case, satisfiability means ultimatum, the value whichever you are getting. If you are getting the value as 1 or high or true, if you substitute this one and you got the value, the output as 1, which is indirectly we said as high because 0 is considered as low, and true also sometimes we are saying. If the output is 1, true or high, definitely we are saying it is satisfiable. Okay, or sat. We are saying it is sat if the result we are expecting should be 1 and we got that is 1, then only we can say it is sat or satisfiable condition it follows. Okay, so this case we are saying as 3 CNF for us. While we are going towards the satisfiability of it, we should say definitely it follows this thing. Okay, so you know, if there is OR operation like 1 or 0 or 1, definitely we will be expecting the result as 1. Clear? And for AND operation, at least there should not be any 0 we should expect within any clauses. So each clause, if within XYZ any of this, what suppose you think we want to satisfy it, the formula is given to sorry, the boolean expression is given to us. That formula, how we can say it's a satisfiable? Let us take an example like the X value is 1 and Y value is 1 and Z value is 1. We need to check whether it satisfies the condition or not. As I told you, or is there means if there will be any 0 also, if at least 1 is present or true is present, any of the values, definitely all clause will be considered as true. You can check. I'm just using this negation. Definitely X value was 1. Right now for negation it converts to 0. Y value is 1. Z value is also 1. Okay. Then AND operation, X value is 1. Then a 0, then 1. Why 0? Because Y value was previously 1. For negation I have converted that one as this 1 and 1 and 1. So for AND operation at least all should be true, then only it will be true. Okay, means we are multiplying it. AND means we are multiplying it, or means we are adding it. For 1, definitely if it is possible within any clause, we should say the clause is considered as true. Okay, so each clause if we are getting as this one, so we can say it is sat. On which condition? If X value is 1, Y value is 1 and Z value is 1, then only we are getting as 1. If some you just change it, might be whether we are getting it or not, we have to check it. You just think, instead of putting Y as a you can say 1, we just say it is 0 for us, whether it is satisfiable or not. You just check 1. I'm just keeping Y value as 0 and X Z as 1. In this case 1 0 1. 1 is there in a clause now. Definitely I said you before it will give you the 1 as a result. 0, it was previously 0, then 1 here, then X value is 1 for 1, then 1. So here the clauses are 1 1 1, so definitely we are getting as 1, which is sat. Okay, so it will be a satisfiable problem for us, or satisfiability is there if you are taking the values of X Y Z in that order. Clear? So you should know what is satisfiable problem or satisfiability or SAT. Before that we should know 3 CNF, 2 CNF, 1 CNF. What are the CNF? CNF is basically product of sums. I'm just writing it. Product of sum. Isn't it? You just check it now. This is a sum, means addition operation we are using, and this is product for us. and within that all the addition functions or addition expression is getting multiplied. That's why it is product of sum. Okay, so for three literals we are taking, as well as three different clauses are there. That is why we are saying it is a 3 sat for us. The 3 sat is 3 CNF. Okay, 2 sat is also 2 CNF. Okay, if 3 CNF is satisfiable, then definitely we are saying 3 sat. It is 3 sat for us. Okay, I hope it is clear for you. Now we will go towards the different category of sat. Okay, sat or satisfiable problem is of two types. One is circuit sat, another is formula sat. The formula set belongs to all type of formula where we are going to use. This is in general, we can say it is just a set for us. Okay, as for the Corman book, it is clearly mentioned. Okay, circuit set, from there will be a circuit given to us, just uh, like I think you have seen in your digital logic. I'm just doing the same thing again to give you the proper idea. These are the combinational circuit, sometimes we are saying. Okay, so the input we will be, these are logic gates. Okay, this is or, I'm just writing it or else you can say in this order we are knowing this one. This is and, we are representing this as multiplication gate. Okay, x1 is an input, x2, x3, there are three input we are providing. So the output we will expect is x1 and, okay, x1 and x2 or x3. Sometimes also you can say x1, x2 or x3. Sometimes also we are saying it is x1, x2 plus x3. Okay, there are, these are the output styling where we are just writing in this order. Okay, suppose a question is given to you, can you convert circuit sat to a sat? If you are converting, then can you convert that sat into 3 CNF or 3 sat? There will be a problem. Okay, so how you are converting, that matters a lot. Like it is given to you, okay, like you know how to find the output. Now our target is circuit sat, which is, this is our sat. Okay, the output we are getting is sat, suppose, because from circuit, using circuit, or you can say combinational circuit diagram, we converted the values in sat. Now our target is, we are going to convert that sat to a 3 sat. Okay, now I'm just saying sat 3 sat. Also we read in this order also, sat polynomially reduces to 3 sat. As per the book I am writing, the left hand side, and as per the concepts which we got, like we know the right hand side always tells us, we know this one, and using this we are trying to find out the answer for sat. This is what exactly it represents. Okay, now the sat value is given to us as per the previous one. I'm just taking this one. Okay, x1 and x2 or x3, it is given to us. Now we are trying to convert to 3 sat. Okay, whenever the question is given, we should have to simplify it. How do we simplify? Next, okay, this is a rule, this is a formula, I've just used it. Next, x2 and x3 both, but x1 is common, but x2 and x3, up to this we can say it is 2 sat. We can say it is 2 sat. Why? Because first thing, 2 CNF is equal to 2 sat. Okay, 2 CNF, whether it is 2 CNF or not, check it here. Or will be present in between, and is between the clauses, and two different clauses that we should have. Okay, within that two different literals. So 2 CNF, we converted to 2 CNF first. Next, what we are doing, we are introducing like as I told you, like we have x2 x3, so we'll use the x3 for here and x2 here. Okay, so how you check x2 then x3, in this way I'm just writing x3 into x3, like it means nothing, like if it is 0 and it is 1, so 1 into 0 will be 0, and 0 with addition with anyone will give you the same as the answer which is previous answer. Okay, that is why we are just using the following rules, and using that rules I'm just converting that into 3 sat. Now we have 2 sat and we are trying to convert to 3 sat. Okay, now a rule we should know, while converting that into three different clauses, two different clauses with three different literals, how do we change it? X1 or x2 or x3, this will convert, then between that we should put and x1 or x2 or x3. Okay, I'm just making this as, like we should know, it is easy for us to understand, x1 or x2 or x3, then and this is just the rule I am using, x1 x2 bar x3, as we are introducing, we have converted this one. Okay, once we have converted, as I told you earlier, like this is equal, this is similar, if you can AND it or if you can multiply it, definitely the same value we will expect, there will no change. As I told you, for satisfiability, the CNF, whether you are keeping the same type of literals, so it will never give you the CNF. Definitely it will, as for the rule it might say, but as for the sat it is not exactly possible. Here you can check, now there are two different like as for the CNF or 3 sat, what it told you, like there should be three different clauses, here there are four clauses, we are merging it now, so we merged it, x2 x3, now x1 x2. So here I think I missed the bar because of this one. Okay, now this is our 3 sat, this x1 x2 or x3, this one is now converted to, this sat is now converted to 3 sat. Okay, this is now converted to 3 sat. Can the reverse is possible or not? Definitely you will be having a question. So from this same example we will go towards that one. Okay, so as it is getting, as it is shown to you, not an issue, I'll take the example for you. Like for 3 sat, polynomial reduces to sat. Okay, or else we know sat, we will be trying to convert that to 3 sat. Okay, the same example we will take because it will be a very much easy for us to understand. x1 x2 x3, x1 or x2 or x3 and x1 or x2 or x3 bar and x1 or x2 bar or x3. Okay, so as I told you, this one, if you can make many AND operations, not an issue for us, because AND operation with the same clause will be converted to one clause that we have seen. Okay, similar time you are writing, like if I am writing 1, so if I am writing 1 into 1, so it will result as 1. If I am writing 1 into 1 into 1, also it will result 1. But these are three different numbers. Now I am using three different positions. Might be it is same, but three different positions I am keeping. So here you can check 1. The same we are going to use here, x1, x2. We are just doing the reverse of the concepts which we have used. Okay, this one is converted now. We are just from 1 we converted to into 2. Okay, now I'm just changing the position, x1 or x2 or x3 and x1 or x2 or x3. I'm just changing it as we have done in the previous, like where we converted x3. Okay, now this will be converted, means this will be, as per the rule, we can change this to x1 or x2 or x3 into x3 bar. This will merge now. Okay, x1, now this will also be merged, x1, x2, x3, x2 with x2 bar, then x3. Okay, now as we know, this will be merged, means we can remove that one because it is having no such use, because we are multiplying both the s and this will give us the 0 as an answer. We can remove that off for a while, not an issue for us to take it. Next, x1 or x3. Okay, now as per the rule, we know if both the element are literals within that, we convert it to 2 sat. Now this is our 2 sat. Okay, this is our 2 sat. We converted to 3 sat to 2 sat, then sat 2 sat to sat. How? You can check it. x1 and x2 or x3. This is how we convert it. Okay, this is our sat. We have converted to sat using like the 3 sat. We have find 3 sat. We are reducing towards a sat. Okay, this is how we convert it. And here we must say all NP problem. I'm just writing a note. First of all, before writing the note, we should know 3 sat 2 independent set. Okay, the 3 sat we know the concepts of 3 sat, and independent set that we know, if you'll pick one or like one vertex, that vertex should not contact, like should not have any edge towards the next vertex which we have selected as independent set. Like the example I'm just giving you once again. Those who are new, kindly watch the previous videos where independent set are being discussed. Okay, so here it is C, here it is D, I am saying. Okay, so for here, like A is attached with B and D, but it is not attached with C. So if I am picking A, I have to remove B and D. I have to remove this one. Then for C, if I am picking A, then I have to pick C. For this case, I must say A, C are independent, set. Okay, these are our independent set for us. This is how we are finding through three set, or like whether we can find satisfiability, or might be satisfiability could be possible or not. You can check from this the previous example. That would be better for us to understand. X1, X2, X3, the Boolean expression is like this, and operation X1, X2, X3, then and operation X1, X2 bar, X3, and operation is completed. This is our three set. How do we complete it? First, you remember X1. This one I'm just converting X1 as a node. We first think X2, this Boolean expression to a graph we are converting first. This is step 1. Step 1, Boolean expression to graph. Step 2, negation, literals to X to X dash. Okay. Next, step 3, find independent set is. Through that we can say it is satisfiable. You just check it. So I've done it. Now how do we convert? First we say all the literals as a node for us, though it is within a clause, so all should be connected. This is step 2 we have completed, sorry, step 1 we have completed. Now the second clause, having this one x1, x2 and x3. Okay, so we are now completing the step 1. Here also x1, x2 bar and x3. Step 1, that we are converting the clause to or expression to the graph. Okay, once it is done, we are trying to connect the literals with positive to negative, or you can say negation towards negation. Like x1, there is no such x1 bar we are having, so x2 to x2 bar we are going to attach. This is the rule for finding the independent set. Through independent set to finding it satisfiable, we have to follow the rules. Okay, otherwise it will not work. Next, here x3 bar, here also x3 bar, we are going to connect it because this literal we are having. Once it is done, step 2 and step 1 is completed. Now we are going to find out the independent set. While we are finding the independent set, always you remember, from each clause you should find, I'm just writing a pick each, pick literal, pick a literal from each clause. Then only we can say it is an independent set for us. Okay, picking of literals from Boolean expression you must write, or you may write it is clause. Okay, clause to a graph. First we have to convert. For each clause we have to convert that into graph. Okay, now I'm just picking one. Either you can pick x1, x2, x3, any of this can be picked. I'm just picking x1. You can pick x2 also, not an issue. Once I'm picking x1, I have to remove this one. Why? Because independent set could not be set. If I'm saying it is x2 will be picked and x1 will be picked at a simultaneously, it is not possible. Why? Because independent set said, if I'm picking one node, I have to remove all the connected edges towards the vertices. Okay, next, for the second node, the first was is first is completed. From the second clause, we have to pick either of this. Like, though x1 is already picked, so we have to avoid that one. We have now two options. Either we can pick x2 or we can pick x3. I'm just picking x2. You can pick x3 dash, not an issue. I'm just picking x2. For that x2, I have to remove this one, and also yeah, this one is connected only. We have to remove this x2 dash. Okay. Next, now towards the third one, I'm just picking this x3 as the next literal, okay, which is our independent set. Definitely we can create the independent set by picking one elements out of it. So if I'm picking x3, so I have to avoid x3 dash as well as this one, as well as the nodes which are connected using this edges. Okay, so the independent set I must write as x1, x2. You can take others too, but you should keep in mind, if I'm picking x2 just for a timing, so I have to remove x2 there. I have two options, either x1 and x3. If I'm picking x1 here, so I have to remove x1 and x2. Only x3 is possible to pick. Okay, this is what we should remember always while we are going to pick the element clearly. Okay, I hope it is clearly understood to you. If any doubt, you may definitely ask. So here, whenever we said it is independent set, take any like these independent set as true. Think this as true or high as one or true. So definitely whether it is satisfied or not, we have already checked. If you want to check it again, I'm just putting the value 1 or 1 or 1, then and 1 or 1 or 0. Why? Because x3 bar is just opposite to that one. 1 0 1. I told you each clause, if 1 is there, so we will be expecting 1 as the answer. 1 and 1 and 1. For the and all should be 1, definitely we should expect as 1, which is satisfiable. Okay, so through independent set also we can make the 3 set to a satisfiable, or 3 CNF to a 3 set. Okay, so we should keep in mind as a note, all NP problems, I'm just keeping in this way, can be reduced to SAT, and this SAT again reduced to 3 SAT. Okay, this conversion is taking polynomial time. That's why we are saying SAT is a king of all reductions possible through NP class. You may say in the direction also, because 3 SAT to SAT could be possible, again 3 SAT to NP class could be possible. So both bidirectional could be possible. This is the note. That's why we are saying SAT is a king of all NP problems. But there are certain problems which cannot be solved using SAT. So nowadays, like, researchers are doing the research on this field. Okay, so this NPP or NP hard NP complete is still a research problem. I hope it is clearly understood by you. If any doubt, kindly comment below. Thank you. Have a good day.